Hello, and welcome to the Felix Instruments AppBuilder video tutorial. The purpose of this video is to familiarize the user with the new AppBuilder software, and will include a brief overview of the menu structures and the various functionalities within AppBuilder. Upon opening AppBuilder, users are greeted with a splash screen that provides information regarding how AppBuilder works, as well as a list of links on the left-hand side that point to direct actions such as creating a blank app or opening an app, as well as accessing more information such as how to create a new app or how to modify an existing app. And there's also a list of projects that the user can select. These are recently opened applications that can be easily accessed with a click of one button. If the user needs to access the user manual electronically, there's a link to that in the top right corner. And basic functionality is available through the file option to open a new project or an existing project, to update the firmware on your device by simply going to the Tools tab or connecting your device to a network. And then documentation and contacting support is also available from the Help menu in this splash screen. As I mentioned, there are a multitude of ways to access an existing app or to create a new app from this splash screen. What I will do is open a demonstration app that I've already created in order to demonstrate all the functionalities of AppBuilder. So I will select Demo App from my list of recent projects. Once the application is fully loaded and processed, you will be presented with this screen. This is the Project tab within AppBuilder, and in this tab, the user is able to edit the name of their application, as well as input any sort of notes that they want to associate with the application. We do have an example on the right-hand side to kind of inform the users as to what information might be useful to keep track of when they are creating these applications. And so things like the number of specimen, the date at which the data was collected, the temperatures, any other variables including maturity level or the regions in which these commodities were measured, as well as the different types of varieties or cultivars of this commodity that were used in the app. There are two icons that you'll notice on this screen, and we will come back to these after I have demonstrated the rest of the application. Next, I will navigate to the Chemometrics Models tab. And this is where the user is going to spend the bulk of their time creating their chemometric models and adjusting those models to perform the way they want them to. Right away, you'll notice a couple things. There are a list of icons right here below the Chemometrics Models tab. There's also a table that contains all the information about each spectral measurement from their instrument. And there's also a graph below that is adjustable in size, and so I'll bring that up here. And this graph is just showing the distribution of reference values in a histogram format. There are other columns along here that each house different information. We have the spectra for each measurement, the color that is used for each measurement in the actual graphs. We have columns to indicate whether this measurement is supposed to be used for testing or for training. Training the model is what actually builds it. Testing it is testing like validation data against the model. We have a predicted value column as well as the reference value column. This is the column where users will paste in their reference values for their spectra. The tags column is a column that houses all sorts of information and metadata about the actual model. In this case, since there was no metadata associated with this measurement, it simply shows the file path to get to the file that was used to import this measurement. But if you specify metadata within your instrument, you can actually see tags such as, the cultivar, temperature levels, or any other kind of information, the region, name of the region where you collected that data. All sorts of valuable information can be sorted with the metadata tags. The lot, this will show you the actual lot in which your measurement was stored. the device ID. This is the serial number of the instrument that was used to collect this measurement. The specimen ID is an arbitrary number, but it is a running number that helps users organize their data and keep track of data when actually going to build these models. And then obviously the created date is the date and time in which the model, or the spectra was created. So let's talk about all of these icons. The first one is export, and this is used to export all of this data that you see within this table into a CSV format to be used for other purposes, or just to be saved and stored as a backup. The import data button. There are multiple ways in which you can import data. You can choose individual files, or you can choose entire folders in which data is stored. So if you have folders that have subfolders, and those folders have subfolders, and they all contain .dat files, then what you can do is just upload that one overarching folder that contains all those subfolders, and everything will be uploaded in the exact order that it is within the view of your desktop file viewer. This helps save a lot of time with having to select individual files. There's also the ability to import a training set from an older device. You can also import a text file in the CSV format, similarly to how you can export the CSV. If you already have a CSV and you need to import all that spectral information, that too can be imported easily. The next button is the database button, and the database feature defaults to Microsoft Access, but it does allow users to set up other databases to house all of their model and spectral information. Right now, the default option is Microsoft Access, but we do have drop-down access for SQL Server or Azure SQL. And to actually access the database and see all this information, you simply click the Browse button. The model icon, this allows you to duplicate the current model that you are looking at. So say you want to reuse the same spectra, but you just want to input different reference values. Duplicating your model is a very useful feature, so you don't have to go through the whole importing measurements process again. If you're using the exact same spectra in that second model. You can also easily remove your models or just add a new blank model. The drop-down menu here actually shows you all the models that you currently have within this application. You can have as many as you want. So if you wanted to assess multiple analytes with a single application, say for instance you wanted to look at dry matter, bricks, and titratable acidity all in one application, with a single measurement, then you would have 3 different models in this drop-down menu, one for each of those analytes. You can easily change the name of the model simply by highlighting it. The setup menu is where you actually can adjust the type of chemometrics you would like to utilize. So we have options built in for PLS, or partial least squares regression, as well as artificial neural network modeling. With PLS, you can adjust the wavelength ranges that you want to use for the model. You can also adjust the number of principal components. You can view your regression coefficients easily. And if you need to copy and paste these, or if you need to adjust these manually, you can easily do that. You can also view or adjust your intercept for the model. For artificial neural networks, you can still change your wavelength range, but now we have 2 new options for adjusting. Instead of, there's no longer a principal component adjustment. Now what you can do is adjust the number of neurons within that model, as well as the decay value. The next option is to train the model. And so this will use all of the spectra that have a check mark box in the train column. It will use them and compile them and use whichever chemometrics you specified in the setup to actually create and build your model. Once that model has been trained, you can then view your model performance. So if you go down to your graph section here, you have the histogram already automatically selected. You can view your spectra. And then you can also view model performance. Model performance will be a blank graph until you've actually clicked train to train the model. So as you can see here, our model has been trained. The large dark line represents the ideal line, and the points here represent the data within the model. Blue will indicate that it's in the training set. Red will indicate that it's in the test set. If they're in both, then it'll display as in the test set. You'll see that it's red, marked red. But you can also see that there's a flash of blue there when you go to select these points. Everything about this graph can also be manipulated, so you can actually change things such as the size of the marker outlines and all these other features within the graph itself. You can say, I don't want to display any training data, I just want to display the testing data. So you would just mark the training data false. You can set the maximum number of records to be altered. So if you don't want to display as much data, you can decrease that value. All that can be manipulated here. So that's all of the basic functionalities within the Chemometric Models tab. So what we'll do now is we'll actually really quickly show you some features that are coming soon. The Device Options tab, we will have this tab available for users in future updates. This will allow users to easily remotely kind of manipulate their user interface and ensure things are where they want them to be within that actual display on their instrument. The Advanced tab, this is where power users can come to actually insert their own specific code if they have different chemometrics that they want to utilize as opposed to PLS or artificial neural networks. You can also manipulate your user interface or any other kinds of operations within the device itself by accessing the code within the device. This all utilizes a low code kind of format, and so we have a lot of annotations here to kind of describe what each of these lines of code do, so that users that aren't necessarily the most computer savvy coders can still manipulate their device to do exactly what they want it to do. This is where you can also easily input code to do things like automatically upload measurements to a server or anything like that. If you have a specific business solution, you can edit this code directly in this tab, and you can compile it with the compiler that we have built in. You also can edit in VS Code, or you can click the browse folder and it'll take you directly to the folder in which this code is located, and you can manipulate it with another application. So let me take you back to the project tab. And I said I would come back to this to finish the tutorial, because after we have trained our model and we are satisfied with the performance of the model, we've adjusted everything we wanted to and it's performing the way we want, and now we want to deploy the instrument or deploy the application onto an instrument. So what we would do is click the project tab, and then I would click create app. And this pops up an option to copy the app directly to a device SD card. So if your SD card was already plugged into your computer, you could easily just deploy it directly to your SD card for your instrument, and you wouldn't have to worry about anything else, and your app would be ready to go on that instrument. Or if you would like to have a backup on your PC, or if you don't have access to your SD card immediately, you can click save this app as a file manually, click OK, and it'll take you to a file explorer and ask you, what do you want to save it as, the name, and then that will allow you to then put this application, in a backup server. But then you can also just drag and drop this file also directly onto the SD card and then go about using it on an instrument. So that concludes our video overview of the new AppBuilder software. If you do have more questions or would like more information, please feel free to visit our website at www.felixinstruments.com.